Recording. Gauss was a German mathematician. At the beginning of the year, we also looked at a Gaussian curve. If you kind of remember that, it looked like an upside down bell curve with a flip on the end. You are going to use a lot of things from elimination because, as you can see here, we have 3 equations with 3 unknowns. So let's write the following notes. Did a lot of writing today. So sorry for that. Okay, so use one or more of the following methods to solve. It's really more like a guess and a check kind of thing. If one thing doesn't work, you're going to try something else. So one tool would be to interchange two equations. In other words, if you don't like up here in the system, if you don't like the order of these equations, you can put them in whatever order you want to. And I'm going to show you what the goal is in a minute, and then we'll talk about different things that we can do to get to that goal. Another thing that you might do is multiply one equation by a non-zero constant. And that's something that we did in elimination. We'd multiply one equation by something and then add it to another one, right? And then the third kind of tags on to the second. Add a multiple of one equation to another equation. And that's something that we did in elimination. So the question is, well, what's the goal? What do we want this system to look like when we're done? What does Gaussian elimination look like? Well, it uses something called row echelon form. And so our goal is to put it into row echelon form. Row echelon, you're going to hear me say that a lot. So highlight that. I can't highlight up here, but you can highlight on yours. And what row echelon form is, essentially, is a stair-step pattern with leading coefficients of 1. And so I'm going to put on here what we're going to end up with for our system of equations, so you can see what row echelon form looks like. So this set of equations here, we're going to finally end up with in the following pattern, if you will. X minus 2y plus 3z equals 9 y plus 3z equals 5, and then z equals 2. This is a 2. So this right here is row echelon form. And you can see that it's a stair-step pattern down. And you can see that the leading coefficients of each equation have a coefficient of 1. That's our goal. Our goal is to have an x, y, and a z term in the first equation, a y and a z term in the second equation, and a z term in the third equation only. Now sometimes you might be missing an a term up here. It's possible, but not usually. All right, so any questions on that before we actually start? Okay, so we're going to go to, you're going to go to your extra piece of paper, and I'm going to go to a new slide, and we're going to actually solve this using Gaussian elimination. In other words, getting into row echelon form. Okay, so since we're moving on from example 1, we're going to look at example 2. But I still want you looking at this right here, because we're going to use this in a minute to talk about what we're going to do here. Oftentimes it's easier to use a matrix to solve a system rather than do all those x, y's, and z's. So we can take this matrix here, and we can get rid of all the x, the y's, and the z's, and the equal sign, and write what's called an augmented matrix. So let's get rid of all those, and we're going to write the following. So the first equation becomes 1, negative 2, 1, and 7. Does anybody not understand where I got those numbers from? I got them from this equation right there. I just dropped all the x's, the y's, and the z's, and the equal sign. So then write the second row for equation 2. You get 3, negative 5, 1, and 14. And then the third equation would be 2, negative 2, negative 1, and 3. That's called an augmented matrix. And we're going to use that to solve the system. We're going to put that into row echelon form. Notice that we still see that haunted word right there. Well, we'll talk about what row echelon form is in a minute. The coefficient matrix essentially takes away this column right here. It takes away the answer column. And you're only looking at the variable terms and their coefficients. That's why it's called the coefficient matrix, and we'll use that next week. So let's just go ahead and write that down, and then we'll forget about it for today. So that would just be 1, negative 2, 1, 3, negative 5, 1, and then 2, negative 2, negative 1. That's your coefficient matrix. So our goal is to take this augmented matrix. We're going to use this one right here. We're going to start off with that one. And we need to get this into row echelon form. Well, let's use this row echelon form up here and take away the x, y, z's, and equal signs so you can really see what matrix row echelon form looks like. So here we go. The first equation up here is going to become 1, negative 2, 3, and 9. The second equation is missing an x. So the missing x becomes a 0. The coefficient of the y is 1, then 3 for the z, and 5 for the answer. The third equation is missing an x and a y, so those both become zeros. And you get a 1 for the z and a 2 for the answer. And this is row echelon form in matrix form. So what we need to do with this matrix right here, notice that we've got a diagonal of 1, 1, 1s. Those are the leading coefficients of 1, and then these zeros represent getting rid of those values down there. And so that's what we have to do here. We have to get a 1, 1, 1, and the 3, 2, and negative 2 have to disappear and become 0. So we're going to use everything that we did above there. We're just going to manipulate things to get to it. So one of the things that MathXL is going to have you do is they're going to give you two matrices, and they're going to give you what's called a rule in between, and you have to figure out how do they go from, or they'll probably give you two matrices and you have to come up with a rule. Or they'll give you one matrix with a rule and you have to apply that rule to the other matrix. So let me just show you what it is that we're talking about. So let's start with matrix 1, which is your augmented matrix. So let's just rewrite it. 1, -2, 1, and 7. And then 3, -5, 1, and 14. And then 2, -2, -1, and 3. And then here's the rule. We're going to take -3, r sub 1 plus r sub 2. This is the notation form of the rule. And then this is what the other matrix is going to look like. That's 2. So the other matrix is 1, -2, 1, 7, and then 0, 1, -2, -7, and the last row is 2, -2, -1, and 3. So can you tell me what happened from here to here? What's different? The second equation has changed, hasn't it? Or the second row has changed. The first and the third row are identical in both matrices. So the second row has changed. How? What is this rule saying that we're doing to create that? Jared? So this is saying multiply row 1. So r sub 1 means row 1. So you're multiplying row 1, all of row 1 by -3, and then you're taking that value and adding it to r2. You don't ever see the work. It's all done mentally, which should make some of you very happy. So here's what they did. They took row 1, in this case 1, they multiplied it by -3, which was -3, and they added 3 to it, and that's where the 0 came from. Then they took -2 times the -3, which gave you 6, added -5 to it, and that's where the 1 came from. 1 times -3 is -3, plus 1 is -2, and finally 7 times -3, -21, plus 14 is where the -7 came from. And so as you can see, we've got 1, 1, and then we have our first 0. So we always want to concentrate on row 1 first, or sorry, column 1 first. So our next thing is to get rid of this 2. There's a various different ways I could get rid of the 2 and make it a 0. What's one way? I could add, well, preferably I'd like to add a -2 to it, if at all possible. So I could multiply the first equation by -2, right, which would create a -2 here, and then add it to this third equation, which gives me a 0. Would that work? Sounds good to me. So let's create our rule. So our rule is going to be to take the first equation and multiply it by -2 to r sub 1. I'm going to spread that out because we're going to do this on the row below because I'm not going to have room. So we're going to take -2 and multiply it to r sub 1 and then add that to the third row. And so we're going to get matrix 3. And so I like to put in the rows that I know are not going to change. So I know that my first row is not going to change. So I'm going to get 1, wrong color. I'm going to get 1, -2, 1, and 7. And then 0, 1, -2, and -7. Those rows are not changing. My third row is. So here we go. Take row 1 and multiply it by -2. So 1 times -2 is -2, plus 2 is 0. -2 times -2 is 4, plus -2 is 2. 1 times -2 is -2, plus -1 is -3. 7 times -2 is -14, plus 3 is -11. Are we okay with that? So now I have my first column is taken care of, 1, 0, 0. I don't want to lose that. So you have to be careful, and notice that I do have my 1 here, which is great. Now don't I want a 0 here? So you have to be careful. In order to make the 0, you might think that, oh, I'll just add row 1 and row 3 together. But what happens? That's going to give you a new row 3. If I add 1 to 0, what's going to happen? You'll lose your 0. So instead, when that happens, take a row that has a 0 above the 0 you want to keep. Take that 0 row and multiply that row by something. So what do I want this to be to make this a 0? -2. So our rule is going to be to multiply -2 to row 2 and then add that to row 3. So write in the rows that are not going to change, which would be the first row, 1, -2, 1, and 7, 0, 1, -2, and -7. And then our third row is going to change. So we're going to take row 2, multiply it by -2, which is 0, and add 0, which is 0. Oh, good gracious. This could not come at a worse time. I have a low battery, that's not good. All right, so we get 0. And then we've got 1 times -2 is -2, plus 2 is 0. Good so far. And then -2 times -2 is 4, plus a -3 bonus gives us a 1. Why do I say bonus? There's row echelon right there. And then let's just finish it up. And then -7 times -2 is 14, plus -11 gives us a 3. So I now have row echelon form, and so you might want to write that down here. Row echelon. And so all we do here is now I want to take my row echelon form and write out my system of equations that I have. So use row 1. That means I have 1x minus 2y plus z equals 7. Row 2, I have no x's, but I have 1 positive y minus 2 z's equals a -7. The third row is telling me I have 1z equals 3. Is there anybody that doesn't know where I came up with those? Okay, so don't I have one of my 3 solutions? Then we're going to use reverse substitution. So I'm going to take the 3 here and plug it into the z up here. So we've got y minus 2 times, instead of z, we're putting in the 3 that we just found, equals -7. So do the math. Y minus 6 equals -7. Add 6, you get y equals -1. And so there is solution 2 out of the 3. And then our final substitution, we now have a y and a z, so we can plug into the first equation. And so we get x minus 2 instead of y. We just found it was -1, sorry. Plus our z, we know is 3, equals +7. So doing the math, we have x plus 2 plus 3 equals 7, x plus 5 equals 7, and x is equal to 2. And then finally, how do we write our answer? Yeah. So I'm going to say that this was step 5, step 6, step 7, step 8 is our answer. So alphabetically, we've got 2, then for y -1, and for z is 3. And so this is our final answer. So we do have time for one more, but let me save this before I go on. So I'm going to rewrite example 1. You should have already had your paper out. I told you to get it out. Y'all don't listen. So here's example 1. Rewrite the system so we don't have to jockey back and forth. And you're going to want to write small. Oops, that's a minus. So this is just the system from the other paper. Now the question is always, what do I do? So you have to have a plan of attack. Your first plan of attack, and you shouldn't be zoning out, I know it's 7th period, but your first plan of attack is to look at column 1. You want this x term in column 1 with a leading coefficient of 1. Don't I already have it? So check off that. Done. I don't have to fix it. If I had to fix it, I might divide the whole equation by that coefficient to get 1, but if that's going to give me ugly fractions, I tend to avoid it. I might multiply another equation by something and add it to this equation to get 1, not 0 but 1, and so that might take care of it without fractions. But I don't have to do anything because that's what I want. So actually this is going to be my first equation in my row echelon form. So that's a keeper. It's a keeper. So then my next plan of attack is the rest of column 1. I need to get rid of both of these x terms in column 1. Wouldn't it be a quick fix to get rid of this x term by adding it to equation 1? This is going to be equation 1, equation 2, equation 3. So you're going to write yourself notes because you're going to forget why you do what you do. So step 1, since equation 1 has x, eliminate any x terms in the other equations. So that's the why for what we're going to do. So we're going to take the first two equations, x minus 2y plus 3z equals 9. I'm going to add to that negative x plus 3y equals negative 4. So a great thing happens, the x terms cancel, and I'm left with y plus 3z is equal to 5. So this is now my new equation 2. So it's going to replace this equation up here. The great thing about this new equation 2 is not only do I have the x term gone, but what's the leading coefficient of this? 1. Isn't that what I want for row echelon form? So this is going to be a keeper. So that's going to be my equation 2 in row echelon. Really all I have to find is the third equation. So write yourself a note. So step 2, this results in a new equation that has a y and no x term. So essentially what my next goal is, since I got rid of this x, negative x here, now I want to get rid of this. What can I do to one of these two equations to get rid of this? I could multiply the first equation by negative 2. That gives me a negative 2x here, and add it to the third equation to get a new third. I like that. You could multiply this by a positive 2 and add it to this equation to get rid of that, and that would work also. But since we just got rid of this equation, I'm going to go ahead and multiply to this one. It really shouldn't matter, but I like to work with what I already have. So I'm going to multiply the first equation by negative 2 and add it to the third equation. So write yourself a note to that effect, because you'll forget, how you got this stuff. So multiplying equation 1, by negative 2 and adding it to equation number 3, will eliminate the x term in equation number 3. Well, all right, so let's move this up a smidge. All right, so we're going to take the first equation, which is x minus 2y plus 3z equals 9, and we are going to multiply that entire equation by negative 2, so just like we would for elimination, and then add that to the third equation, 2x minus 5y plus 5z equals 17. So we're going to rewrite that whole system. We get a negative 2x plus a 4y minus 6z equals negative 18. We didn't touch that third equation. And now we're adding these two, and a lovely thing occurs. The x's disappear, and I am left with y, negative y, minus z is equal to negative 1. So at this point, let's write what we have. So we have 3 equations. So step 4, you now have, we're just going to take a little breather here. So our first equation, we kept x minus 2y plus 3z is equal to 9. Then we got our second equation from this one right here. So that's our second equation. Y plus 3z is equal to 5. And then we just developed this equation right here as our third one. And so we have minus y minus z equals negative 1. So from here, let's determine what we're going to do next. Is this row echelon form? what's missing? We have these two. We need to get rid of the negative y, and this coefficient in front of z needs to be positive 1. So how do you propose we get rid of this negative y? I can add those two equations together. So I'm going to move this over to the second column. I had a feeling it was going to do that. Hold that thought. Okay. So let's start back up top. And then again, you're going to write yourself a note, a somewhat lengthy note, because you're going to forget what you did when you got home. So, see if I can write it legibly. 5. Now, all but the first x has been eliminated. From the first column. And that's always your first goal. Get rid of all the x's in column 1. Go to work. On column 2. You need to eliminate negative y from equation number 3. Add the new equation 2 to the new equation number 3. So that's what we're going to add together. That's what we decided to do. Y, so that our y's would cancel. And then we end up with 2z is equal to 4. So that's now our newest form of equation 3. Because we're keeping equation 1 and 2. Is that finally in row echelon form? Nope. What's wrong with it? Leading coefficient must be 1. So that's an easy fix, isn't it? What do we do? You're going to say divide by 2. Math Excel probably won't like that. So what are they going to want you to say? Multiply by 1/2 is exactly. Because technically, I mean, I don't see a problem with dividing by 2. But, you know, you might put that in there and they go, no, that's not correct. So bear in mind that multiplying by 1/2 is the same as dividing by 2. So again, you're going to write yourself a note. Yes, absolutely. So number 6, last big note. Now all you need is a coefficient of 1 in front of the z. Multiply by 1/2 or divide by 2. And so we have 2z equals 4. And you're going to divide by 2, because we all like that better. And you finally get z is equal to 2. That's a terrible 2. So the good news is, of course, hang on, group. Okay, so the good news is we actually have one of our 3 solutions, don't we? We know what z is, plus that's our third equation. So let's actually write what our final row echelon form is, just so that we have that written down in case you're asked for that. So part 7 is, now you have, and this is your final, now you have our first equation, never changed, x minus 2y plus 3z equals 9. Our second equation became y plus 3z equals 5, and z is equal to 2. So this is your official row echelon. And there are some questions in your Math Excel that will ask you to just go find row echelon. That's it. Stop there. Don't solve. But we're going to solve, of course. So, step 8. Can't we at this point, if I know that z is 2, can't I plug 2 into this equation and find y? And then once we know y and z, can't I plug y and z into this top equation and get x? So you're going to from the bottom all the way up to the top. So here we go. 8. You're just doing reverse substitution. So you're going to take y plus 3, and instead of z, we're putting in 2, and we got that from here, equals 5. Y plus 6 equals 5. Subtract the 6, doesn't y equal negative 1? And that gives us answer 2 out of 3. Then 9, we're going to substitute into the top equation. So we have x minus 2, and instead of y, we're putting in the negative 1 because we got that from here. And then plus 3 times, instead of z, we're putting in 2, and we got that from here, equals 9. So use your math. X plus 2 plus 6 equals 9. X plus 8 equals 9. Subtract the 8, doesn't x equal 1? And that gives you part 3 of 3 answers. But of course that's not truly the solution. Are you dying now? Kind of. Alright, last step. The solution is, you cannot leave your answer like that. You have to write it as a triple ordered pair. And it must go alphabetically. Sometimes they're going to use A, B, and C, D, E, and F. Your variables in your systems aren't always going to be X, Y, and Z. So alphabetically, which comes first? X, which is 1, then negative 1 for Y, and then 2 for Z. And so this becomes our absolute final answer right here. You're really glad you came to math class today, Patrick, aren't you? Yeah. All right, so you're not going to really ever write it out that much, but trust me, when you go home, you're going to go, what? How'd you get that? Especially if you didn't write that stuff. Okay, so let's go back to the very first page of your notes. As soon as I have everybody finish writing this down, I don't want to get anybody upset that I moved. Any questions or concerns while we're here? Actually, I'm going to give you something a little easier to do. You might find it easier. We're going to actually use matrices to do the row echelon form. Yes? Mm-hmm. It goes x, y, z. Are we good? Okay, so we're going to go back to slide. Okay, so we're going to solve another matrix example. So we'll call this example 2b. And your system is x minus y plus 2z equals negative 3, and 2x plus y minus z is equal to 0. Then negative x plus 2y minus 3z is equal to 7. So we're going to start with our augmented matrix. So I'm going to get rid of all the x's, y's, z's, and equal signs. So we have 1, wrong color, 1, negative 1, 2, and negative 3. And then for the second equation, the coefficients would be 2, 1, negative 1, and 0. And for the third equation, negative 1, 2, negative 3, and 7. So then we have to decide what we're going to do to this column. We've got the 1 that we want, but we need to get rid of the 2 and the negative 1. So we're going to start here at the 2, and we want to make that a 0. So I could either multiply this row down here by 2, so that that's a negative 2, and add to the second row to get 0. Or I could multiply the first row by negative 2. That would make that a negative 2, and add to 2 to get 0. So I think we're going to do multiplying the top row by negative 2. So write out your rule, negative 2 multiplied to row 1, and then we're going to add that to row 2. And so that's going to give us matrix number 2. And so our first row is not going to change. We get 1, negative 1, 2, and negative 3. Our second row, however, is going to change because we're going to take the first row, which is multiplied by negative 2, add it to 2, that's going to give us 0. Then we're going to take negative 1 times negative 2 is 2, added to 1 is 3. 2 times negative 2 is negative 4, plus negative 1 is negative 5. And negative 3 times negative 2 is 6, added to 0 is 6. And then row 3 does not change. So we now have 1 and 0. We've got to get rid of this negative 1 and make that 0. We could quite easily just add the first row and the second row together to make that happen. And so let's go ahead and do that. I forgot the notation there. And so we're just going to add row 1 plus row 3. And that's going to give us our third matrix. So the first row will not change, 1, negative 1, 2, and negative 3. Our second row doesn't change, 0, 3, negative 5, and 6. But our third row, when I add the 1 and the negative 1, I get 0. Negative 1 and 2 gives me 1. 2 and negative 3 gives me negative 1. And then negative 3 and positive 7 gives me 4. So now I've completed column 1. I've got 1, 0, 0. My next goal is to get this 3 right here to become a 1 so I can get it in that row echelon form. So I could get this row multiplied so that this number here is a negative 2, which added to the 3 gives you a 1. But the problem is, if I add these two, So if I multiply this by a 2 to get a negative 2, I'd have to multiply that by a 2. Added to the 0 gives me a 2. And I lose that 0. So I want to multiply this final row down here, which has a 0 here. I want to multiply this row by a negative 2. And so that's going to enable me to keep the 0. So our rule is going to be multiply row 3 by negative 2, and then add that to row 2. And that's going to give us our next matrix. So our first row stays the same, 1, negative 1, 2, and negative 3. Our second row is going to change, because I'm going to multiply row 3 here by negative 2, which is 0, and add 0, which is 0. Then 1 times negative 2 is negative 2, plus 3 is where we get the 1 from. And then negative 1 times negative 2 is positive 2, plus the negative 5 is negative 3. 4 times negative 2 is negative 6, plus the 6 is 0. Did I mess that up? Let's see. So 4 times negative 6, nope, that's right. We're all good. So 4 times negative, oh, that's right, 4 times, I knew something was wrong. 4 times negative 2 is negative 8, plus the 6 gives us our negative 2. And then our third row is not going to change. So we've got 0, 1, negative 1, and 4. So now all I need in column 2 is for this 1 here to become a 0. And I can't just add row 1 and row 3 to make that happen, because I'll lose my 0 here. But I could multiply this row right here by a negative 1, and then those two will combine to give me a 0. So that's our rule. So we're going to take negative 1 and multiply it to row 2 and add that to row 3 to get our next matrix. Whoops. Let's group those. And we still missed that. Let's see if I can. Okay, so we are going to end up multiplying row 2 by that negative 1 and adding it to row 3 to get our fifth matrix. So the first row doesn't change. 1, negative 1, 2, and negative 3. The second row is not going to change. 0, 1, negative 3, and negative 2. But the third row, we are going to take negative 1 times 0 is 0, plus 0 is 0. So that's good. We didn't lose our 0. And then 1 times negative 1 is negative 1, plus 1 is 0. That's what we wanted. Then negative 3 times negative 1 is 3, plus negative 1 is positive 2. And finally, negative 2 times negative 1 is 2, plus 4 gives us a 6. So the last thing that we need is for this value right here to be a 1. And then we have it in row echelon form. So the easiest way to do that is really to take this entire row and just divide it by 2. Or MathXL would probably prefer you write your rule as multiplying row 3 by 1/2. And so we end up with our last matrix. The first row doesn't change, 1, negative 1, 2, negative 3. The second row doesn't change. And the third row, we're going to divide everything by 2. So we get 1 and 3. What's nice about this is that we can now move everything up just, oh, of course not. So then our last step is to do substitution. So I'm going to write this matrix in row echelon form using x, y's, and z's. So this first row gives me 1x minus a y plus 2z's equals -3. The second row gives me no x's, but I have a y minus 3z is equal to -2. And the third row gives me no x's or y's, but 1z equaling 3. And so what that does is it gives me one solution out of the two. And so then I'm going to do reverse substitution, and I'm going to go from the bottom up. So I'm going to put this 3 in for that z. So we get y minus 3, and instead of z, we're using the 3 that we just came up with, equals -2. Y minus 9 equals -2. Add the 9, you get y is equal to 7. And that's 2 out of our 3 solutions. And then our last substitution, now that we know z and y, we're going to plug those in for the z and y here in that first equation. So we get x minus, instead of y, we're going to use 7. And then we've got plus 2 times, instead of z, we're using 3, equals -3. So we've got x minus 7 plus 6 equals -3. X minus 1 equals -3. Add the 1. X is equal to -2. And that gives us our final solution. And then last but not least, we need to write it as a triple ordered pair in alphabetical order. So x is -2, y is 7, and z is 3. And this is our truly final answer.